In this illustration, we intend to simulate seismic performance of beam to column connection with opening in the Abaqus software. In this problem, a cyclic loading is applied to the end of the beam, and then the hysteresis diagram of the model will be drawn. In this picture, the hysteresis diagram obtained from the Abaqus software has been compared with experimental results. In this picture, the deformation obtained from the Abaqus software has been compared with the experimental results, and as you observe, there is a good conformity between the results obtained from the Abaqus software with those mentioned in the article. Actually, as it can be observed in the picture, the buckling has occurred both on the beam flange and the beam web. The buckling caused the stiffness of the model to decrease, and this can be clearly observed in this diagram. Actually, we intend to simulate this article in the Abaqus software. The article is entitled Seismic Performance of Steel Beam to Column Moment Connections with Different Structural Forms. I will click on Create Part. I intend to create geometric shape of column. Continue. The length of the flange is equal to 250 millimeters. The length of the web is equal to 250 millimeters. The length of the column is equal to 2050 millimeters. In the next step, I will enter step module. Click on Create a Step. This problem is done in two steps. That in the step 1, an axial load will be applied to the top of the column, and in the step 2, a cyclic loading will be applied to the end part of the beam. As you observe here, first an axial load of 400 kilonewtons is applied to the column, and after that a cyclic loading will be applied to the beam. Click on Create Boundary Condition. Select Initial Step, then select Displacement Rotation and continue. I will select the bottom of the column. Done, and close all the boundary conditions of displacement for it. In this manner, the bottom of the column will become absolutely fixed. In the next step, I will click on Create Boundary Condition, select Displacement Rotation and continue. I will select this reference point. Done. Here I will close all boundary conditions of displacement except U2. OK. As you observe here, the beam flange and beam web will become buckled. Actually, the flange buckling and web buckling can clearly be observed in these pictures. As previously mentioned, due to the cyclic loading being applied to the beam flange and beam web are buckled, and the buckling occurs both in the beam flange and beam web. Actually, these results are quite similar to the laboratory results. Here, the laboratory results can be observed, and as mentioned in the article, the buckling has occurred both in the beam flange and beam web, and we had already obtained just the same results from the Abaqus software. In the next step, we intend to draw the hysteresis diagram of the model. Actually, we intend to draw this diagram in the Abaqus software. Here, the horizontal axis is displacement and the vertical axis is force. I click on Create XY Data, select ODB Field Output, continue. Here, select Unique Nodal. First, I will select RF2, then select U2. Here I will select Set 6 that is related to the place of cyclic loading and click on Save. I will click on Create XY Data, select Operate on XY Data, Continue. Here, I will select All Reaction Forces, then select Sum option, then click on Add to Expression, and then on Save As. In this manner, all reaction forces will be added up together. In the next step, I click on Combine. First select U2, then select Force and click on Save As. Here you observe the hysteresis diagram of the model. As you observe, the results obtained from the Abaqus software are so close to the laboratory results. Now I will transfer the diagram to the Excel software in order to compare that with the results mentioned in the article. The first column is displacement, the unit of which is millimeter. The second column is force, the unit of which is Newton. Here, the diagram having been drawn with red color is the one having been obtained from the Abaqus software. As you observe, the results obtained from the Abaqus software are really close to the results mentioned in the article. Actually, the results obtained from the Abaqus software has a very good conformity with those gained from laboratory tests, indicating that the problem has been correctly simulated in the Abaqus software. As you observe here, due to the buckling having occurred in the model, decrease of the stiffness can be clearly observed in the diagram.